Okay,
Hey,
I think,
David.
hey, I almost said good morning to you, Nilam. I realize it's actually 3 p.m. in the afternoon here for us. But
That's right.
hello, everyone, and welcome to Hackster Connects. I'm David Tischler. I am a Hackster Pro. I'm by day a developer relations engineer at Edge Impulse. I will get get our comments open on the right-hand side in just a moment and let us know where you're from, where you're watching from today. But joining me today is Nilam Ruparelia from Microchip. Do you want to say hello and introduce yourself, Nilam?
Yes, absolutely. Thank you, David. Hi, everyone. Thanks for joining us today. My name is Nilam Ruparelia. As you heard, I'm from Microchip, and I'm responsible for Edge AI related business aspects, strategy, go to market, business development, applications, etc.
All right. Well, thanks for joining us today. I'm excited to get to know more about both your particular role there at Microchip and a little bit about what Microchip has been up to lately. I got a little bit of a sneak preview. Um, I'm just now having my coffee, and like I mentioned, it's 3 p.m. here. I'm in Phoenix, Arizona, and I'm just now making it to my coffee because it's been a busy morning. I just returned from Embedded World North America.
That's right.
And yeah, I was telling you that the other day, Neelam. And I actually think I may have noticed you were drinking the coffee as well.
Well,
Uh,
I was finishing
okay.
tea.
That's good enough too.
That's
I
right.
switch to tea in the afternoons most days, but I'm just
That's
now
right.
getting to my coffee because I'm catching up on all of my pings and all of the social media from a couple, 3 days now at Embedded World North America in Anaheim. And, our topic today on Hackster Connects is Microchip's Edge AI roadmap and the future of embedded. I just returned from Embedded World. There, I don't know, could have been maybe 500, 600, 700 booths there, all different vendors, all parts of the ecosystem. I mean, it's a great show for anyone who's ever been to Embedded World in Nuremberg. Think the same thing.
That's much bigger.
And
Right? Nuremberg have a
well,
much bigger.
Nuremberg is bigger. That is true. North American show is a bit smaller,
500,
but
600 booths for North America is actually pretty big. Is it bigger
Yeah,
this year than last
well,
year?
it was bigger this year. Maybe it was you know what? Maybe it was 200, 300. I don't know. I didn't count. I should have taken a clipboard and counted.
No,
But
you felt it, right? You felt 500. It must
yeah.
be bigger than last year.
The thing is though, as I walked the rows, every booth was talking about Edge AI. We've really reached a point where Edge AI is becoming a massive talking point among all of the vendors. Everybody was focused on Edge AI. Microchip, no exception there, had some really, really cool demos and really cool parts. I was looking on my phone before we hopped on the stream to see if I had any pictures of your booth, but it looks like I didn't get any. Um, you had a house demo. It was really cool for smart home and some of the Edge AI applications. I'm going to ask you about your software stack in a moment,
Yeah.
so on and so forth. But before we get into that, yeah, I just wanted to say that Edge AI was everywhere at the show. So I think that we'll have a great conversation today.
Yeah,
Um,
absolutely. Absolutely.
which is a perfect transition point then. Do you want to tell us a little bit about your exact role at Microchip
Yeah.
and a little bit of your background and what you're responsible for there?
Yeah. I can do that. But
Yep.
before that, I want to thank you for taking this time and hanging
Ah,
out with me and introducing me to Hackster community. I haven't. I've been kind of visited on Hackster community pages. I think after we set up this talk, I went a few more times, and I'm fairly impressed by the amount of activity and type of projects people do. And I know Microchip is involved in that. I personally been not very involved, but I'm looking forward to be more involved myself and our team at the Edge AIBU in Microchip that will be more involved. And of course, thanks to Hackster for hosting this as well. A little bit about myself. Yeah, I am now responsible for the business and application market, etc. for Edge AI across Microchip. I'm in San Jose, California. We have many different offices across the globe, and we have a large enough campus here in San Jose. In fact, it is this year, like you say, Edge AI seems to be coming of age,
Yeah.
age, and becoming a lot more mainstream, right? I mean, I started looking at this almost 5 years back. If I go back to my personal history, for last 20, 25 years, I've been more of a communication guy, 5G, 4G, and also communication infrastructure. So OTN, Ethernet, that's been my background. I've been in semiconductor industry forever, and started way back in last century. So I'm
last century makes it sound. To say it's been a while.
Yeah, you can see the hair's gone. So, but the Edge AI is rejuvenating. So I thought since around 2015, 2017, as AI becoming more common, I started looking around and I'm like, okay, where do we play? I was in a company called Microsemi in those days, and Microsemi was acquired by Microchip. And I'm like, as soon as that acquisition happened, I'm like, okay, you know what? Now we got the right forum for AI on the edge. There's been a lot of IoT movement forever, but IoT mostly brought connectivity. It is the smartness what makes the difference. And Edge AI is bringing really is the same thing. It's no more just Internet of Things, it's smart Internet of Things. And we all like to call it Edge AI. And so we have seen a lot of interest, a lot of trial projects. Many customers come and talk about, hey, these neural networks can be implemented to achieve this particular function, that particular function, and we kind of studied that hard, evaluated, talked to a lot of software people in our team, and at some point we started formulating strategy around it. And this year we actually created a specific business unit for Edge AI. So as you might know, Microchip is a diversified semiconductor company, mostly known for microcontrollers, but we also build, in microcontrollers, we build 8, 16, 32-bit across the board, but also processors, FPGAs, Ethernet silicon, connectivity silicon like that, USB, PCI Express. In fact, we are one of the major supplier for data center AI in connectivity. And so if you look at all of those aspects, I mean, we are in AI per se, but all of those product line, there you go.
I had to just grab it off the floor right here. This is the RISC-V part, but I'm listening. Yeah, you do have a very diversified portfolio. You're absolutely correct. From the IP up into the MCU space across, like you said, 8, 16, 32, into the CPU, MCU, and FPGA world. Yep, this is the RISC-V part. I forget the name of this one.
There you go. Yeah, RISC-V. And RISC-V, we have a couple of different product categories.
Curiosity, that's what it was. The Curiosity board.
So what we that's actually a pretty nice board. And
yeah, it is. I love this board.
Reasonably low cost and very it's very popular. We sell a lot of those.
Yeah, that's a good one.
So we decided that Edge AI is now mainstream enough that we should put strategy behind and more investment behind it. And that's why I'm one of the 3 people who step up and say, okay, let's form a team and create a business unit. Where our charter really is to work across these different product lines, microcontrollers, microprocessors, and help our customers implement AI solution on that. So what do we do for that? We actually have 2 or 3 different toolkits. So one of them we own as a BU, business unit. But then we also build applications and solutions around it, and we help our customers to use those tools, applications, solutions to implement Edge AI in their applications. So that's in a short form, maybe long form, uh, that we do. That's my role and my business unit role at Microchip.
No, that's awesome. I mean, yeah, I think quite honestly, I think the same as what you've observed, which is that okay, so as I mentioned, my full-time role during the day is with Edge Impulse. I've been at Edge Impulse about 3.5-ish years now, and when we began, we focused on what was called tiny ML, and over the years, the narrative and the verbiage has shifted and really become Edge AI. Prior to Edge Impulse, I was also in the IoT world, and you're correct. It was really more about the connectivity, getting things, obviously, as the name implies, but getting edge devices, as we would maybe now call them, connected. And that could have been cellular, that could have been, satellite, NB-IoT, whatever.
So many ways you connect things.
Yeah, a million different ways. But in the more recent years, it really truly has become mainstream. Even as I'm thinking back 3, 4, 5 years ago, embedded world would have been all about really a focus on, I don't know, a couple hundred megahertz faster core or, whatever. And, the latest the innovation in MCU or CPU technology. I don't know, SV2 or whatever. But now I walk the floor and it was all about the solution. What is being, what is the application layer, the solution layer? How are you helping the customer? I don't know that I saw a whole lot of booths really showcasing, it's 10% faster than the previous generation. I don't know. I didn't really see a lot of that kind of marketing material. It's not, it doesn't matter how many megahertz. It's really about what can you do to solve a problem. And,
That's right. That's right.
Yeah.
And that's what we see as well.
Yep.
Like I said, I've been looking at this space for since 2015 practically, but
Yep.
especially intensely in last 3-4 years. And more often than not, what we find clients struggle with is not, hey, how can I get a little more megahertz, or for that matter, tops, right? I mean, there are
Yep.
companies
Tops.
there are products out there with 2 tops, 5 tops, 10 tops. And just because you move from 2 tops to 5 tops doesn't mean you can do it better, faster, etc.
Nope.
In a raw format, yes, the extra power helps, but then it comes with its own additional cost of either power consumption or a silicon price, or the longevity of supply, or the reliability. Depends on who the silicon provider and what format of the silicon you're using. You can create more problems by trying to just go after
Yep.
higher frequency or higher performance
I
than the
just
problem
spent
you solve.
I just spent 3 days at the booth talking
Yeah.
about exactly that. Do you really need more tops? What are you trying to accomplish? Where does your device actually live? What is the definition of the edge? Is it in the forest or is it in the factory? Because in the factory, you have power and connectivity. In the forest, battery life is more important. So it's funny. I just had all of these conversations at the data set quality and all of that, and we can even get into that in a few minutes. But I want to you're talking about the solution versus a few more tops. Does a few more tops really matter? And I know, I'm kind of looking through your website, and you were mentioning that you have a new business unit and really some of that solution architecture. And I was looking at your MP Lab machine learning development suite. And is that something that you are responsible for there, or have some context on that? Are you able to give us a little high level overview of that?
Let me share that, and then we'll come back to the solution because that's really
Yeah,
what I
that's
But
yeah,
let's talk about, maybe I'll talk about just a breadth of microchip uh, quickly on silicon, and then
yeah.
get to the
Mhm.
SDK or toolkit, so that
Yeah, it's exactly, but you're spot on with the analysis there because I was wondering how do you get to the solution? Okay, you've got a customer and they have a problem and you are going to build a solution and I'm wondering, okay, well what's the toolbox to do
correct.
that?
Yeah, there are layers of all this solution, right? So you got silicon at the bottom, then you need a toolkit, and then you need data set, and then you need models, and then you need to train
Yep.
them and make sure it's all
Yep.
working together. So maybe we go up the layers and
Yeah.
a quick introduction of each of them.
Yep.
So first of all, microchip is fairly unique in the industry that we enable edge AI or tiny ML, whatever phrase you want to use,
Yep.
down to 8-bit microcontroller. Why is this important? Because there are so many, like you mentioned, forest or tower top or other reason. There are so many applications that needs extremely low performance, but they need a little bit more intelligence, and they need lower cost and lower power consumption and so on. And so we got a broad portfolio of microcontrollers. So we enable down to 8-bit. Most of applications, of course, in microcontroller domain resides on 16-bit and 32-bit. On 16-bit specifically, we have a DSP engine that also allows additional acceleration, and on 32-bit, we have higher performance silicon, so that works. More often than not, the microcontroller portfolio we find so many applications for linear sensor applications, right? So, for example, monitoring temperature, voltage, current. By the way, microcontrollers monitor temperature, voltage, current, pressure,
Yeah.
IMU all day long.
Yeah.
But now you're gonna put a neural engine that can monitor more than one variable together or two or three variables together and identify a pattern that you could not do that before. And now suddenly it becomes a lot more valuable. For example, hey, I have a fan on my server power supply that turns on if the temperature rises at some point.
Yep.
How about you actually sense the rising temperature, the rate of temperature rise, and turn on the fan before the temperature hits the threshold? Now you get a better performance out of server. Now to do that, you actually need to measure not just temperature, but also current along the rate of rise of current along with the temperature. That's kind of a really good example where microcontroller are really useful in applying machine learning. And so we call it a linear sensor or a sensor analytics type of
Yep.
application. Then the second layer application we think about is audio human machine interfaces. And for that, you need a little more performance, and we use higher performance microcontroller, 16-bit, 32-bit, and microprocessor. And then a third layer, we look at it as a vision-based, camera-based
Yeah.
application, which is a 2D flow of information and needs higher processing capability. So you need a ARM A7 class CPU that we have with Neon instruction set, and or we actually use acceleration inside an FPGA and enable one or more cameras
Yep.
analytics around based on camera plus audio plus other things together. So it can be multi-sensor as well, but at a higher data rate. So we got this three silicon platform on which we can implement different types of algorithms or neural networks. For each one of them, we have a appropriate toolkit. So the
Okay.
MPLab ML that you mentioned is really great toolkit that allows our clients to bring in data, analyze data, organize data, pick up a model from Model Zoo, and train that model to apply on a microcontroller. So it's a fantastic toolkit for end-to-end ML for microcontroller applications, and also to some in microprocessor applications. So that's where that MPLab ML works comes into play.
Okay, so
There's so
that's then
many,
down in the MCU space. You're
yeah,
talking
they're primarily for
sensor data,
MCU.
time series, linear. Yeah,
Correct. Correct. Time
got
series linear. You could use it for audio. It has some cool stuff around audio as well,
it. I'd
but it's
seen
really
that.
meant for that class of silicon.
Yep.
Then the middle layer, which is main audio, single camera, video type of application where we find a broader resources of models available from open source, and people like to bring in their own stuff and so on.
Yep.
We utilize standard TensorFlow, ONNX type of approach. That product, MPU, SAM A7 class of product, supports Linux as well.
Yep.
So anything you can do on Linux works. And by the way, another great toolkit we have for that class of product is working with Edge Impulse. So we actually have many customers who use Edge Impulse toolkit, and your FOMO models is actually very popular on our silicon. And so that, if you're looking for something in the mid single digit, kind of price point, you're looking at a low cost enough, and that silicon is fantastic with that. And then the third toolkit we have, which is FPGA, which allows really one or more than maybe two up to four real-time streaming camera analytics based on that, has a DSP engine converted into neural accelerator on FPGAs, has PCIe interface, has the Ethernet interface. That is an engine that can be really good for a lot of visual applications. And for that, we have, because it's FPGA, we have a toolkit called Vector Blocks, which then takes the neural engine into, neural networks into implementing it on RTL basis. And it works alongside a soft CPU on the same chip. But all of those details are hidden from users, and we literally enable users to stay in the AI domain. Any ONNX format model brought onto Vector Blocks works. So we got three different kits for three different, the right tool for the right project,
right job, exactly. And that's interesting because there's two very interesting pieces that you touched on here. The first one is that you have multiple toolkits based upon the platform, whether it's MCU, MPU, CPU, or FPGA. Which then allows you to come to the second interesting point, is that you're sort of abstracting away and not worrying too much about the hardware, because the customer's going to come to you with a problem that they want to solve. It might be that, like you mentioned earlier, they want to turn a fan on before a room reaches a certain temperature, and you can do that with a neural network all the way down on an 8-bit microcontroller. Great. You don't need vector blocks and an expensive FPGA for that. But they don't necessarily know that. You don't want that end user, that customer, to go down the road of exploring an FPGA if they don't really need to. Let the customer just come to you with the problem. We want to turn a fan on in advance of a rise in temperature. Okay, well, here's how we can help you to do that. And then the middle layer, like you said, even with Edge Impulse, we absolutely support the SAMD7 right out of the box. FOMO works great on it. Microchip has been at lots of our events over the years. It works wonderfully. I must have one of those around here somewhere as well. The Curiosity was within arm's reach, but I know I've got the other one here too somewhere. And then all the way up to, like you said, with the vector blocks for really, truly real-time multi-camera input. That's a computer vision use case. Yeah, you do. You need more power, more capability. But customer or the end user is going to come to you with I need to ingest multiple camera streams. They're not going to say, I need an FPGA with a certain number of.
That's right. And that is actually the right approach.
That's not well, then the first question is, what are you trying to do that you need this many tops or LUTs, or I forget how the FPGA classifications work, but it's definitely the right approach by all means. Yeah. And I want to glance at the clock. We don't necessarily have a hard stop, but we're at 25, so we'll go a few more minutes. But I did see a couple of questions come in. Let me see.
Yeah, let's go through a couple of questions and we come back to solutions, and then we can decide level of
Yeah,
interest.
exactly. So the first one was, well, it's kind of a broad question. It's a bit general, but I like it. What the future of edge AI looks like going forward and into the future. And I
Yeah.
might throw you a curveball here, Neelam. I'm going to let you answer that yourself, how you think the future of edge AI looks and what the future holds. But while you're doing that, I'm going to bring up a press release from yesterday.
Yeah, yeah. So yeah, feel free to bring the press release. For for me, I think the future of edge AI is simplistic, is bright and very strong, and this is why you're doing what you're doing, I'm doing what I'm doing, right? We are not
Yep,
here to work on something that's backward looking. Obviously,
yep,
the way I look at it is just look back and see how microcontrollers evolved. Right? It's very easy. Microcontrollers evolved 8-bit, 16-bit, 32-bit. Now we from there it become microprocessor, compute, GPU, all kinds of compute engine evolved, right? Um, the usage of those compute engine in a non-data center application is probably the most prevalent usage. Is the data center application that has evolved lately, and the cloud network has allowed a lot more intelligence density. But the reality is, you and I live in real world,
yep,
and we walk around our house in a neighborhood and go on the flight, and the real world devices are required in everywhere in real world, and 99% of those devices, just like we're talking about, at best are connected.
yep.
The smartness is something that's needed. And most of those devices where you need real-time application, you're not gonna want to rely on cloud-based. Also, you need privacy. You need low latency in human-machine interface. So I think the edge AI ultimately is a much bigger phenomena. It is a fragmented market. You can't just put 1,000 servers in one place and declare edge AI done and create a
No,
chat
no, you
GPT.
can't.
Right? You can't, right?
That's not how
So
it's.
it will take its own time. It's a 20, the way I look at it, it's a 20 years phenomenon,
Yep.
or maybe even longer. And you will see every year there will be more AI, which is intelligence or smartness, thrown onto the devices as we go along, as companies figure out how to find the right amount of data set, how to tweak the engine, and how to enable the solution. I have no doubt that we are looking at 20 years growth of edge AI. And this is why we are doing what we're doing. We're committed to, grow along with that.
Yeah, these are not technologies that are going to happen overnight. These are long-term shifts in how we operate. No, I agree completely with that. Um, if we can bring my screen in, I don't
Yeah,
know if
feel free.
I'm able to add it or not. Might need Sean behind the scenes to do it. Let's see if we can bring my screen share in. Maybe. Here it comes. So I did see this yesterday,
Yes.
just yesterday,
Yeah.
from announced again at Embedded World, and I was looking through this PR, and this Siva New Pro family of NPUs is actually another NPU core that Edge Impulse does support. So this will be interesting in your next generation of products, and it goes all the way down to the smallest embedded applications down into the MCU class of devices. So now you're talking about adding dedicated accelerator NPU IP all the way across your product stack. And like you mentioned earlier, there's simple time series things maybe don't even require
Right.
an NPU, but if you're able to add an NPU and accelerated AI, then it makes me start to wonder what else can that microcontroller actually do. So yeah, turning the fan on in advance of the temperature reaching a certain critical threshold might be nice, but kind of opens the door to what else can you do?
Yeah.
Yeah. So,
So,
no,
so
go
it's, a,
ahead.
it's a good point. Thanks for bringing up the press
Yep.
release. Yeah, we partnered with Siva,
Yep.
and we are committed. So, if I step back,
Yep.
Microchip is committed to enable our customers implement Edge AI across the range of applications,
Yep.
across different markets. So we operate in communication, industrial, defense, aerospace, you name it. Most of the infrastructure markets, including consumer and appliances and so on. And so when you think of this, there's 1,000 beachfront opportunity, 1,000 beachfront war, whatever the way you look at it, there are many different tools you need to address all of those things. And we're committed to address that in a complete stack for
Yep.
entire set of applications, a complete stack. So what the way we are approaching is we have a broad silicon portfolio today, and that can address, almost 30, 40, 50%, 60% of applications we come across today, maybe even 70%, depending on the actual use cases and so on. More often than not, we are able to find a more compact, better created model using in today's silicon to address most of the applications we come across. But we understand that this world is not standstill and there's need for additional firepower.
Yeah.
And so we are getting prepared for that additional firepower or the AI processing power with that. And so that's where this partnership it will come into play. And we're building a roadmap that will allow us to create next set of products that is accelerated products, right?
Yep.
I think that's all we can say on that today. It's a Siva press release with our partnership.
Yeah,
In due
no, I
course of
didn't mean
time, you'll
to.
hear more from
No, I
Microchip
didn't mean to
itself.
bring it up as I need top secret information from you. I meant to bring it up as what you're doing is innovating, and you're talking about that 20-year plan, right?
That's
You're
right.
you're essentially building out a portfolio of product. This is only one small piece of your entire product stack.
That's right.
I'm just simply saying, now what else is next? The question was all about the future, right? And in order to, well, I mean, quite honestly, not be left behind and like you mentioned earlier, being left in the past, I simply saw it as, oh, wow, continuing to innovate, continuing to add more and more capability to your product range. Yeah, no, I didn't mean to try to pry in secret information out of you, Nilam. I just simply
I'll
meant,
tell you what else is coming, right? So I think
yeah,
what we've done in past few months is really getting better understanding of where do customers get stuck. So everybody wants to implement AGI, and I
yeah,
find two or three different scenarios that are more consistent from customer experience pieces, right? And I'm sure people listening to this would connect to that as well. We find customers either they know what they want to implement, but they don't know how to.
yep,
Some of them they know how to implement, but they get stuck with figuring out how to get data to make sure that they can train the engine for it. And believe me, I have a customer who has complete product definition, everything ready to go. Then they learn that, data collection for this project might take a year. And they go, oh my God, we didn't think it would
yeah,
take that much here. Now,
I've heard that
our fault
story as
detection,
well.
you need to create faults
Yeah,
in the
where's your data
system to
set? Yeah,
collect data,
where's
right?
the flaws? Where's your anomaly detection? What data? You can't build an AI
Correct.
model with no data.
Correct.
We talked about this the other day on
Right. So we
when
find
we
that
did our briefing. I could go down that rabbit hole for another entire hour. No, I could go down that rabbit hole for multiple hours. It'll be a future live stream for us.
so that's an example. Then there's a
Yeah,
keyword spotting, and so we
yeah,
find, okay, anybody can create a keyword spotting using any hardware kit and plug in open source model. But does it work when two people talk together? Does it work in a noisy room? Does it work in a parking lot? And then you suddenly start,
no.
and then people get, the customers get, oh my God, I didn't know that. I thought this is very simple. I thought
Yeah,
I can just
yeah.
I can put, open source model on a toolkit and I got a demo. Yes, I got a proof of concept. That is 30%, maybe less of what you
Maybe
need,
less.
right?
I can give you an example of this week. As I've said several times, I went to Embedded World. I was responsible for a demo using our new Arduino Q supported board, and I built I don't know if anybody saw on social media, this racetrack, a little slot car going around a track with some computer vision camera up above using FOMO, like you mentioned, as the car goes around. Okay, well, simple enough. I built it right here in my home office. I had a camera on a tripod stand aimed down at the track, and took pictures to create my data set. And I was pretty comfortable that the model was working well. It could identify the car going around the track. Yeah, great. I put it in a box, I shipped it to Anaheim, and I got to the show, opened up the box, put the track back together, put the camera back up on the booth, and the model detected nothing. The car was most certainly going around the track. I promised the car was traveling around the track. Camera didn't see a thing because the lights in there
That's right.
were big, bright, fluorescent lights.
Correct.
And, I just have my office lights here. And the camera was much higher. The perspective was different. The camera angle was different. There were some shadows that had gone across the track from some other things. And so, you know what? I had to get new data. So I started taking pictures Monday night in order to rebuild the model now to make it more representative of its
In a bright light, yes.
current. Yep.
Yes.
Yep.
Yes. So yeah, I mean, we are all living through this. So the point I was making is, we are right now in the mode of creating what we call production-ready solutions for a range of applications, which is more common and kind of portable. So what you will see from us coming up very soon is solution that is not a proof of concept, is not created in a garage by just one day, but have been thought through in practical use case scenario and wrung out the the creases in the solution. And of course, it will still be customized by actual customer usage,
Yep.
because each one of these things will be used in different scenarios by different customers. But what we realize is that we need to bring a set of solutions that is ready to be customized just for the specific use case,
Yeah.
but it's other things around it in terms of environmental factors. And by the way, that's not just it. You also need to enable that on a low power enough silicon, cost competitive silicon, has to have the right interfaces. So that's what we're working on, and you'll see over next, let's say, 3 to 12 months period. To your question on what's coming, we're bringing in set of solutions that way more than proof of concept. Somebody can take it as it is and productionize it, but it will also be customizable. But it will not have those basics problems, right? So that's kind of one of the things we're doing. I think the other thing we're doing is, as you show in the press release, we're making sure that we're building next generation silicon that more often than not, people think of edge AI as another AI and just think about, hey, how do I get my AI problem solved? But you also have to get the edge problem solved, right? You need to
Yep.
have the longevity of supply, you need to have low power, you need to have reliability. and security. And so we are making sure that our products come up with those things way out of the box, and therefore it becomes Edge AI ready, both
Yeah,
solutions
it's
for
ready
testing.
to go. That's
Correct.
exactly it. Everything necessary is there from the as like we began the conversation, all the way from the bottom layer up to the
Correct.
top
Yeah,
layer. You
you
have a
need to put
complete,
the entire stack. So
yeah,
we are committed to full stack
yep.
solutions. And by the way, that doesn't mean you have to take the whole stack. You can pick and
No, you pick and
choose.
choose. Yeah, you pick
It's
and
a
choose.
configurable
Mhm.
module, but you need the full stack to make sure that every one of the layers of the stack are really well defined and well designed and well structured.
Yep. No, that's
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 where
the
we.
absolutely perfect way to put it. Well, I'm looking at the clock. I do see there's a few more questions in here. I'm going to
Yeah.
give you, since I threw you that curveball earlier, I'm going to give you an easy one. I'm going to give you a layup.
Okay.
This one is going to be the easiest question ever you've taken in your life. And then after that, I think we'll probably wrap up and we
Sure.
can close it out. Okay, now this one comes from Instagram. And the question is taking embedded systems design a good idea for someone who wants to innovate on edge AI?
Absolutely, yes. I think that's the easiest
There
question.
it is. There it is. After I hit you with the tough questions with a press release, now I give you the easy one.
Yeah, yeah. So I mean, but to do justice to the question, right? Is taking embedded is a good idea to Edge AI? I
Yeah.
think so because look, just exactly like I was saying,
Yep.
there is a reason why it is called Edge AI.
Yep.
The edge piece, which is the embedded piece, is also equally critical as the AI piece. Now, AI piece, there is a lot of dialogue, a lot of high, not just hype, but there's a lot of efforts around in community, many different communities, and that gets better and better by default because you know most of the engineering world is focused on. But that you cannot forget the edge piece. You can't take the data center approach where you just throw more silicon and more power. You have to make sure that that thing works in the rugged environment needed, in the
Yep.
50 degree desert
Yeah.
in Saharas or Arizona for that
Hey,
matter,
hey, we hit
right?
50 in the summer here on occasion. Like I said,
Yeah,
I'm in
right. In your
Phoenix.
neighborhood. But
Yeah,
it
I
have to
have, in
work.
fact, I have attempted to put a Raspberry Pi on my
Correct.
roof of the house and even shaded. It, I mean, it reaches within, as soon as the sun comes up, it was 107 degrees C.
And by the way,
It
even
melted. It didn't last.
exactly. And by the way, and just not that it works, but that when you design it, you shouldn't need to redesign it every 2 years because the chip supplier
Yep.
discontinued, because the
Yep.
chip supplier wants to change the fab. You need to
No.
depend on supplier who can, sustain this products and supply to you for many years because you don't want to redesign the whole thing again and again.
No,
So
I
there
don't
are
want to
so
go
many
up on
things
the
about
roof.
edge.
I
Yeah,
don't want to go up on that roof in 107
exactly.
degrees C. So,
So the edge piece is hard. Edge piece is very hard, and that's part of the reason it takes time. IoT took quite a bit of time to just getting connectivity. I think getting smarter with edge AI is going to take time, but
yep.
that's where the value is. That's where you add value to make your product really appealing to the end user and really sustaining in the end environment that you want to go apply it to. So that's a kind of
All right.
longer answer to your
Yeah,
layup
that's
question.
okay. I mean, the short answer was yes,
Yes,
absolutely yes. That's but you know what? You gave some
you're
really
preaching the
good
choir.
context because
Yeah.
you're right. And I've seen this and I did field a few questions over the course of the week about, you know, generalized, or if you want to just call it what folks just see kind of in the headlines in the media of AI and they think of Chat GPT. That's not the same thing as edge AI. If you want to innovate on large language models, vision language models, transformers, and you're talking about big GPU rack scale data center AI, okay, that is certainly a great career, a great field, but that's a different line of study. versus edge AI and learning embedded systems and how these bits play into the overall role.
The
So
way
yeah,
AI is starting on this growth curve,
yeah,
and the growth ramp should go on for a while versus infrastructure. Wall Street's arguing every day, is it
yeah,
peaking already or not, right? So
yeah,
that's the other way to think about it. But anyway, it's for
yeah,
individual to think about it. For
yep.
me, edge AI is there for 20 years, and I think that's what we believe and we are committed to go for.
All right. Well, Nilam, thank you very much for your time and your wisdom. Because I think we gave folks, quite honestly, a crash course in Edge AI in a mere 46 minutes. I think we covered a lot, and there was a lot of really good information. And we could actually, like I was saying earlier, we could have gone a lot longer because I've got about 100 more questions for you, but I'm gonna I'm gonna wrap it up here. So I'll do our standard closeout, which is to make sure to join Hackster.io. Be sure to sign up, be a part of the community. There's about 2 million makers and engineers across the entire ecosystem. There's hands-on projects, live sessions, these Hackster Connects, Hackster Fireside Chats. There's all kinds of other sessions and events as well. And other industry insights you're not going to find anywhere else. So by all means, like, subscribe, click the bell, click whatever icon or logo on the platform of your choice, but make sure to follow, and we'll see you next time. And thanks again for your time, Nilam. I really appreciate
Thank you. Thank you, David. Thank you for hosting it and having a really great conversation. And thank you to Hacksters joining us. Thanks for attending this. And feel free to reach out to Microchip if you have
Yep.
questions on our products, etc. And of course, like you say, join Hackster.io and follow this community.
All right. Thanks, everyone. Have a great rest of your day. Bye, all.
Bye.